Welcome everybody to the first video of Open Chemistry Online. In our first video we're going to be learning more about units, about measurement, and about how we keep track of these things in chemistry. Because as you may or may not know, chemistry is the study of matter and change. And if we want to understand matter and how it may change into other forms of matter or into energy by rearranging and all of the equivalences that are to do with the world around us, which chemistry is so intertwined with, we will need to learn about certain ways of measuring, certain conversions from one type of measurement to another. For example, between the number of atoms and the mass of those atoms. And so this is really a foundational topic in chemistry that if you're able to really get a great command of the technique shown here, I think you'll find that it serves you well in all of your chemistry endeavors moving forward, as well as in other courses or any science that you need to use units. So without much more, let's jump into the video. Alright, so as we're learning about units in chemistry and how measurements in chemistry have not only their value but their units, it's always important to remember those two parts, right? When we have something like 100 meters, that isn't just a number like 100, right? It's got two parts. It's got 100, which is the value of this measurement, and then it's got meters, which is the units, right? And so this would be distinct from, say, like 100 feet or 100 seconds or 100 chickens, right? The units really matters and tells us a very, very important part about the measurement. And a couple of different measurements with their value and their units are like 500 grams, 6.02 times 10 to the 23 atoms, and so on, right? Two different parts, the value, which tells us how much, and the units, which tells us what it is. And these units are just so essential in chemistry because when we have units that are like compound units, such as density, which is a mass per volume, the equation for solving for density actually mirrors the units, right? If you take the mass of something and divide it by its volume, that will give you the density. And we can remember density based on that formula, right? Density equals mass over volume. But we can also just look at the units for density and see, well, that's grams per milliliter. And therefore, it must be mass, which has units in grams, divided by volume, which has units in milliliters. And so if we really can embrace this idea of units, it really can cut down on the formulas that we have to remember and get to just a much more fundamental unit-based scientific approach. The units alone, again, tell us the equation for density. And so one of the most important things here in chemistry is converting from one unit to another, because chemistry is the study of matter and its change, and we want to know about different qualities of a certain measurement. So if, for example, we have 400 milliliters of a fluid and we want to know how many ounces this is, how can we convert? Well, we can use the following approach, because we also know that 1 ounce is equal to 29.57 milliliters. So that's what we know that's kind of always true, right? This is going to be our conversion. 1 ounce equals 29.57 milliliters. But let's consider what happens if we take this equivalence, right? 1 ounce equals 29.57 milliliters, and divide both sides by 29.57 milliliters, including the unit. Well, we'll see that we get the following, right? The right side of the equation will turn into 1, while the other side will say, well, this is 1 ounce divided by 29.57 milliliters. And so what we see here is we've taken what we know to be equivalent, right? 1 ounce is equal to 29.57 milliliters, and we've shown that we can change this into a fraction, right? A conversion factor, I'll call this, because this conversion factor is equal to 1, and mathematically we can always multiply anything by 1. We don't have to do it to both sides. We can do it just to a numerator. We can multiply anything in math by 1 and we'll still maintain its accuracy, always. And so because this conversion factor is equal to 1, we can multiply by it, upside down, right side up, whatever we need to do. And so if we are going to deal with this problem, we have 400 milliliters of fluid, and we know that 1 ounce is equal to 29.57 milliliters. We're going to want to start our dimensional analysis approach by writing down the value that is specific to this problem, rather than a value that's kind of true always. So go ahead and pause the video here and consider which of these two pieces of information is specific only to this problem, rather than always true, true here, true on Mars, true, in any other type of conversion problem you'll need to do. Go ahead and pause and let me know what you think. All right, hopefully you were able to come up with an answer, and that answer is the 400 milliliters of fluid, right? That is the specific amount of fluid we want to convert in this problem. The fact that 1 ounce is equal to 29.57 milliliters, again, this is always true, and we're going to use this information to convert, but we do want to start the problem with what we know specifically to the problem itself. And so let's write that down first, right? We'll start with our 400 milliliters of fluid, and then what we're going to want to do is apply that conversion factor that we know to always be true. And so we're going to multiply by that conversion factor something over something else. Now, what we want to do is we want to put the units of milliliters in the bottom. Because if we do that, then we have milliliters in the numerator for our 400 milliliters, essentially on top of the problem, and milliliters is going to be in the denominator of this fraction we're multiplying by, and that's going to cancel out our milliliter unit. In the top goes our fluid ounces because that's what we want to convert to, right? And so this is where a little creativity comes in if we have a multi-step conversion. In this case, pretty straightforward because we're just going from milliliters to fluid ounces. Next thing is pretty simple. We just put in those values that we know to be true from the conversion. So 1 goes in the top, 29.57 goes in the bottom. Now we can multiply. As we do so, we're going to cancel out our milliliter units, which leaves us with a unit of fluid ounces. And now we just have to evaluate the value. So multiply all the numerators, divide by the denominators, and we end up with 13.53 fluid ounces. And that's our answer, right? So again, the big take home is that we can use these conversion factors that we know, either way, right side up, upside down, depending on what we need to convert from and to. And then we can kind of follow our units in order to do our conversion and not have to remember divide in this case, multiply in this case, and those types of individual things. So go ahead and maybe pause and try the next one. I'll work through the answer here in a second. Let's find the volume in milliliters of a 49 gram iron object, given that we have the following density of iron. Go ahead and pause the video, see if you can work that one out, and we will discuss. All right, let's take a look at what you were able to come up with. Remember, the first thing we want to do is we want to start with what we know specifically to this problem, right? We know the density of iron is 7.847 grams per 1 milliliter, and also that we can use that upside down, right? Milliliters over grams, grams over milliliter, depending on what we want to convert from and to. But we do want to start out with the 49 grams because that is the unit and value that is specific to this problem, the measurement that's specific to this problem. And so we start with 49 grams. We want to multiply by this conversion factor. Grams is what we want to undo and convert to milliliters. So grams needs to go on the bottom because in that way we're going to cancel out grams. And so we go ahead and apply our values. 1 milliliter in the top, 7.847 in the bottom. Grams cancels with grams, and we're left with a value that has a unit of milliliters. In this case, 6.2 milliliters. So again, right, it really doesn't matter what you're converting from or to. Follow the units, and you will be able to end up with units that are the ones you want. Okay, now what if we don't have a single conversion that can do this job in, one ratio, right? Say we have an object we know weighs 0.414 kilograms, we want to convert into ounces, and all we know are the following two conversion factors. Well, remember, right, each of these conversion factors can be expressed as follows, right? As either 1 gram over 2.2 pounds or, the reciprocal, and the same for the 1 pound and 16 ounces. So we basically kind of want to use this as a puzzle to get from the units we have to the units that we want. And starting with what we know is always very good to do, right? And what we know specific to this problem is this 0.414 kilograms. So let's start there. The first thing we want to do is we need to undo these kilograms, and that's going to get us to units of pounds, right? Because that is the conversion that we have. Kilograms in the denominator, pounds in the numerator. Unfortunately, we can't go right to ounces with this particular conversion factor that we have, right? I mean, there is, of course, a conversion factor from pounds to ounces, or rather from kilograms to ounces, but we don't really have that one in this problem. You don't always have a single conversion factor that gets you exactly from one unit that you want, from one unit that you have to a different unit that you want. And so seeing how we can use multiple conversions is really very useful, right? And so within this first step, we're going to get away from the kilogram units and to units of pounds. And now we can undo these units of pounds, right? Because we can apply a second ratio, right? We've undone our kilograms. This, if we evaluate it, will give us this 4.14 kilograms in terms of pounds, but we want to go all the way to ounces. And so we can do another conversion, pounds in the denominator now, because we want to undo pounds, ounces in the numerator, because that is the unit that we want to end up with. We have 16 over 1, that is the values that go with that conversion, and we end up with something in terms of ounces. Multiply all the numerators, multiply all the denominators, and do our division, and we end up with something that is 14.6 ounces. And so, in chemistry, right, we're not only going to be looking at these converting from different types of mass or density conversions, but knowing these fundamentals and that we can follow the units is going to be so important when we start looking at chemical reactions, when we want to know how much of some new product results from a certain amount of a reactant that we start with, or if we want to know something like how much energy comes off of a reaction. And if we know that a certain amount of energy comes out of a certain amount of a chemical, well, that we're going to be able to use just like these conversion factors as well. Now, I know that this notation, right, it is good notation. This is just, math with fractions and all that, but I know that not everybody loves fractions. One thing that you can do is you can lay it out in the following table, and this can be helpful in getting organized, right? The first conversion, let's put as the unit with its value over 1, right? Everything that's just laid out as a unit can also be expressed as a fraction over 1, right? Divided by 1 still gives itself, just like multiplying by 1. Then we kind of line up our conversion factors, right? The next one we want to do is we want to undo kilograms and go to pounds. The one after, we want to undo pounds and go to ounces. And so now we multiply across the top, multiply across the bottom, and we really are doing the exact same thing, canceling our units as we go, right? We see we have kilograms in the top and bottom, pounds in the top and bottom, and therefore those cancel. Keep in mind, this is the exact same thing we're doing above, except it's laid out in kind of a table that might make it a little easier to compute if you're not loving fractions, right? But I would encourage you to do the fractional approach if at all possible. It is really good for your continued math skills, but if this helps you get the right answer, definitely go for it. It is the exact same thing. So units again still cancel except for the last numerator, and that gives us the value that we want. 14.6 ounces, 14.6 over 1, which again is just 14.6 ounces. Okay, so to wrap up here, let's go ahead and try a practice problem, right? We say that a barrel of oil is exactly 42 gallons, and the question is how many liters of oil are in this barrel? Now, this is a little bit harder, but what factors do we have, right? Well, let's look up, a few factors here, right? We can say, well, 1 liter equals 1.057 quarts. We know that a quart is equal to 0.25 gallons. And with this, I think we have enough information to solve the whole problem. So go ahead and pause the video and see if you can lay out your dimensional analysis approach and see if you are able to come up with the correct answer, which again is how many liters of oil in 1 barrel. All right, hopefully you've had a chance to practice this problem. Again, I've provided these conversion factors here, but in the future, right, if you have a need to convert from one unit to another, you may need to look up the various conversion factors. There is a conversion table in the OpenStax book, or you can sort of research on the internet conversion from blank to blank. The most important part here is this dimensional analysis technique and how to stay organized when we're actually doing a conversion through multiple factors, right? Again, we have 1 liter equals 1.057 quarts, and we can express this as a fraction. 1 quart equals a quarter of a gallon. We can express as a fraction in either of these two ways, right? Remember that we can always multiply by the numerator and the denominator by a value to simplify a fraction. This is, again, multiplying by 1, a very important and powerful mathematical concept. And so from here, what we want to do is start with what we know to get to what we want, right? What we know is we start with 42 gallons. We need to go away from gallons, and the unit that we have that we can convert from gallons into is quarts. So let's go ahead and apply that conversion. And once we have quarts, we actually have the final conversion, which gets us to liters. And so we can convert from quarts to liters that way, giving us the final value of 159 liters. Now, again, right, we could, of course, find a gallon to liter conversion. That's probably an even easier way to do this that would give you only a single conversion factor and should give you the same answer. However, in chemistry, right, we may not always be able to just use a single conversion, and so being able to set stuff up like this will really help for further problems and is going to be something that we target in future videos here in Open Chemistry Online. So thank you very much for watching the first video, and I will see you in the next